This short video answers some often asked questions about transposing formulas. I was asked quite recently if I could explain how to rearrange the voltage drop and adiabatic equations. How do the letters on the right hand side suddenly appear on the left hand side? And more importantly, in what order should we make the transposition? And only last week, a Facebook contributor expressed their own concerns at how they found this subject difficult to comprehend. So let's unravel a couple of formulas and show you exactly what we are doing to the formulas in each step. Here's an example. How do we make the top formula into the bottom formula? They are both the same formula, the adiabatic equation, just transposed, but they look so different. How do we change the subject of the formula? This is what transposition is all about. If we have a voltage drop formula, how do we change it so that we can find the length of the cables, for example? There's an order of operation for any formula, and most times we should follow this order so that we arrive at the correct answer, and all will become clear. For short, we call the order of operations BEMA, B-E-M-A. This stands for removing brackets first, then carrying out any exponent operations such as squares and square roots, followed by multiplication and division, and lastly addition and subtraction of numbers. Let's see. The first example here is a simple bracket. The numbers 2 and 3 are in a bracket, and the bracket is multiplied by the number 7, and then that answer is multiplied by 3, and we have an answer of 105. In the second example of brackets, we can look at this two ways. We can add the numbers inside the brackets first and then multiply them, so we have 8 times 11, which is 88. Or we can take a longer approach and multiply each term in the first bracket with each term in the second bracket. This way we have 3 multiplied by 6 is 18, and 3 times 5 is 15. Now we have 5 times 6 is 30, and lastly 5 multiplied by 5 is 25. Add the four numbers together, 18, 15, 30 and 25, and we have the same number as the previous method. Exponents are squares and square roots, sometimes cubes and cube roots in electrics. The blue square shows 28 multiplied by 3 squared. We must calculate the 3 squared first. So 3 squared is 9, and then 9 multiplied by 28 is 252, the correct answer. Do the calculation wrong and you get an answer in the 7,000s. Nothing like the correct answer. 2 squares, 2 exponents that are multiplied together can be worked out as 2 separate squares first and then multiplied together. Or we can multiply the 2 numbers first and then square them. So 3 squared multiplied by 2 squared can be calculated as 9 times 4, which is 36. Or as 3 times 2 first and then squared, which gives us 6 squared, also 36. The same method can be applied to the cubes of numbers. 3 cubed multiplied by 5 cubed can be 27 multiplied by 125, or it can be 3 times 5, which is 15, and then cubed. In both methods, the answer is 3,375. Note that this method works for multiplication, but does not work for addition. If everything is multiplication or division, then the order of operations does not matter. Done correctly, whatever the order, the answer should be the same. Likewise, if everything is addition and subtraction, then the order of operation does not matter. In this example, it doesn't matter what the order is or where the subtraction appears. The answer will always be 9. When multiplication and division is mixed with addition and subtraction, then we must complete the multiplications and divisions first before adding or subtracting. In this example, we must multiply 12 and 3 together first and then make the addition of 5 to give us 41. If we add the 3 and 5 first to get 8 and then multiply by 12, we will have an answer of 96, which is totally wrong. Always preserve the correct order. Multiply first, add second. Having said that, be careful when you need to add and when you need to multiply. The division signs here are keeping pairs of numbers in groups. At position 1, we must add 4 and 4 together first, as they are kept in a group by the division sign below them. And below that, at position 2, are the numbers 2 times 2, which should be done next. Now we can move to position 3 and multiply 6 by 5, followed by position 4, which is 4 minus 1. Done correctly, we now have 8 divided by 4 added to 30 divided by 3. Simplify this and we have 2 plus 10, which is 12, and that is our answer. Let's move on to transposing formulas, or rearranging as we sometimes call it. Get the hang of these examples and you will have the mental tools for most formulas. Take this formula for example. The yellow oval shows that S is the subject of the formula. S is the answer to all those terms on the other side of the equals sign. If we want to, we can rearrange or transpose all the terms in the yellow shape to make the green shape, and now we can find the value of t if we put numbers into it. T is now the subject of the formula. These are the adiabatic equations. We can write them as shown at the bottom too, with multiplication signs shown, and this is my preferred method most of the time. They mean the same thing, but I find that they are easier to read like this. So what are the steps to change from S equals something to T equals something? Let's take a look. Remember Beamer. Well, there are no brackets in the formula shown here, but there is an exponent, the square root, to be dealt with first. There are 8 easy steps shown here to change from S equals to T equals. Step 1. We start out with S equals the square root of I squared multiplied by T and all divided by K. In step 2, we squared both sides to remove the square root. We now have S squared is equal to I squared times T divided by K squared. On to step 3. Multiply both sides by K squared, and at step 4 we cancel out the K squared on the right hand side to leave us with S squared times K squared equals I squared multiplied by T. At step 5 we divide both sides by I squared, and at step 6 we cancel out the I squareds on the right hand side. With step 7 we've finished the transformation with T as the subject. We have S squared multiplied by K squared and divided by I squared is equal to T. At step 8 we can, if we wish, flip the whole formula to put T on the left hand side and everything else on the right hand side. We now have a nice tidy looking T equals S squared multiplied by K squared divided by I squared. Job done. There is another way, another easy way to transpose any formula. Follow this method. If we look at the voltage drop formula with VD as the subject, how do we change this to a formula for length with L as the subject? When you are faced with too many letters and symbols, simplify the visual impact and allocate a letter to each symbol as shown here. VD has been allocated the letter A. MVAM is a complete term and should not be separated into separate letters, so we allocate the letter B to MVAM, and likewise keep IB together as a term with the letter C. Finally, allocate the letter D to the symbol L for length. In the yellow box, we now have a much easier to transpose formula, at least visually. Make sure you write down what symbols the letters A, B, C and D represent. This is our task. A is the subject. Now make D the subject. At step number 1, we have our starting formula with A as the subject. To remove the number 1000 from the bottom of the formula, we multiply both sides by 1000 and cancel out on the right hand side. This leaves 1000 at the top on the left hand side and removes it from the right hand side. At step 4, divide both sides by B and cancel out on the right hand side. At step 5, we are left with C and D on the right. We need to move C from the right to the left, so we divide both sides by C and cancel out on the right as shown at step 6. Finally, at step 7, we have the finished transformation with D on its own as the subject of the formula. At step 8, if you wish, you can flip the whole formula left and right to put the letter D first on the left hand side. I always do. I think it looks tidier and gives us D equals A times 1000 divided by B times C. Now we can put the terms or symbols back into the formula. We had D equals A times 1000 divided by B times C. We have our list of what symbol or term each letter represents. All we do now is copy them over. And now we have the transposed formula for length. L equals VD multiplied by 1000 and divided by MVAM multiplied by IB. And yet another way to show you, following on from the last method. With practice, there can be less steps as you begin to recognise shortcuts. We're not going to show the cancelling out process on this slide. Instead, because all the symbol letters are either multiplied or divided, we are going to simply move them across the equals sign. If the letter is at the top on one side, it moves to the bottom on the other side. In other words, as it crosses over the equals sign, it changes from a multiply to a divide, or vice versa. At step 1, we start with A as the subject. Step 2, we move 1000 from the bottom to the top on the opposite side. At step 3, move B from the top on the right to the bottom on the left. Repeat at step 4 with C, move C from the top on the right to the bottom on the left. And we have the letter D on its own. D is now the subject of the formula. At step 5, we've chosen to flip the left and right sides to put D on the left hand side. Our finished formula is D equals A times 1000 divided by B times C. We show here exactly the same method but using the voltage drop terms instead. With practice, it becomes easy to just shuffle whole terms about from one side of the equation to the other. At step 1, we start off with VD as the subject as before. In step 2, we move the number 1000 to the top left. Step 3 is relocating the MVAM symbol from the top right to the bottom left. Step 4 completes the transformation as we move the IB symbol across the equals sign to the bottom left. And step 5 flips the finished formula left and right to put L for length on the left hand side. The transformation is complete with L equals VD multiplied by 1000 and divided by MVAM multiplied by IB. The VD formula has an important difference between VD equals and L equals that we must be aware of as electricians. Let's take a look. Shown on the left, if VD is the subject of the formula, then VD is the actual voltage drop, what you might measure with your test meter. In this transposition, the formula is being used for calculating the actual voltage drop in a circuit with a known length. We know the cables are 40 meters long, etc., etc., so what is the expected voltage drop in the cables? On the right side of the page, we have the transposition for L equals something. If L is the subject, then VD is the maximum permitted voltage drop according to the regulations book. We are calculating maximum length of a cable that will not exceed the maximum permitted voltage drop. If the maximum permitted voltage drop is X volts, then what is the longest length of cable that we can use? I will often write in ACT for actual voltage drop or MAX for maximum in my calculations to avoid any confusion and mistakes. Thank you for watching, it really is appreciated, and I hope that you found this video useful and that you've added some more knowledge to your mental toolbox. In the description I will leave links to 2 more LearnElectrics videos about formulas, which include worked examples, test questions and answers to help revising for exams. Please subscribe to our channel to get access to all of our videos, and remember to click on notify to be sure of not missing our next video. And don't forget that you can also type in LearnElectrics into the YouTube search bar to go directly to our channel at any time from any computer or smart device. We are constantly adding new videos to our channel, so don't miss the next one. And once again, thank you for watching, and we hope to see you again very soon.